Hey everyone, hope things are going well for you. We're going to look today at angles of elevation and depression. Now, angles of elevation and depression are two things that are very similar. It's just making sure you understand the difference between the two. So here's what I want you to consider. If you're looking straight ahead and you see an airplane flying in the sky, your eyes move from straight ahead upwards. The movement of your eyes is the angle of elevation. So on this picture here, this black line represents the vision you looked. You're looking up at the airplane. That angle there is the angle of elevation. Now, conversely, let's say you're standing on a cliff and you're looking down at the city. The angles that your eyes move are what are called the angle of depression, and that would be this direction. Okay, so your angle of elevation is what angle your eyes make when you look up. The angle of depression is what angle your eyes make when you look down, and it always starts from straight ahead. The one mistake I see a lot of people make is if you're standing and looking on a cliff, and hopefully this drawing makes some sense. So you're up here on the cliff, and you're looking down at a figure. So this is the way your eyes are looking. A lot of people will put the angle of depression right there, and that's not the case. Okay, it has to start where your eyes were looking straight ahead and coming down. So be very, very careful to make sure you understand that angle of depression. All right, so let's see if we can make some sense of this. So it says a parasailer is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to a parasailer is 48 degrees. Estimate the parasailer's height above the boat. All right, best way that I've found to do these problems is to draw yourself a picture. Okay, so here we go. There's my boat. Okay, that's sitting in the water. I've got some guy up here on a parasail, just like that. Okay, the parasailer is attached to a boat with a rope 300 feet long. Well, this should make sense then that that is 300 feet. That's my rope holding the guy up. The angle of elevation from the boat is 48 degrees. Now remember, that is always measured from the horizontal, from the straight line. So that right there would be my 48 degrees. I want to know how high is this parasailer from the boat. So I'm looking for this right there. Now what you guys will notice is a lot of these pictures will create right triangles. And that's extremely important because we can now use trig to solve these values out. So I've got this 48 degrees here. I'm asked to find x. Well, based on that, that's my opposite. So I've got my opposite side. This right here is my hypotenuse. So I've got opposite, hypotenuse, which is sine. Okay, so sine of 48 degrees equals opposite, which is x, hypotenuse, which is 300 feet. And now we go to our calculator. So I've got sine of 48, which is 0.743. I'm going to multiply that by 300. And what that tells me is that guy is 222.9 feet above the water. And there you go. And that's how you can tell what this angle of elevation is and how it relates to some of these problems. All right, so there's parasailing. If you've ever done it, it's a lot of fun. Don't do it if you're scared of heights, I guess, though, because 223 feet is pretty high. All right, let's look at this next one. So Superman is flying through the air at an elevation of 1,300 feet. So let's see what we got here. We've got Superman flying through the air here. There's his cape. And he is 1,300 feet above the ground. Okay, so we'll say that this is 1,300 feet. He looks down at the people at an angle of depression of 31 degrees. So he's looking down at 31 degrees. Now the question is, where is that 31 degrees? Well, what you got to remember is it comes from the horizontal. Okay, so that right there is 31 degrees. Be careful. That's a very, very common mistake. How far away are the people? So what we're really looking for is this right here. And so I've got my right angle right there. Well, there's a couple ways you can do this problem. First off, this angle up here at the top starts out as 90 degrees. Right? So it's my vertical and my horizontal, which make 90. The angle of depression is 31 degrees, which means that this remaining angle would have to be 90 minus 31, or 59 degrees. So you can start with that. The other option is this and this are parallel. They're both the horizontals. What that means is since this is 31, this is 31, that right there is an alternate interior angle, so it's 31 degrees as well. So you can look at this a couple different ways. It really doesn't matter which you choose to use it as, but both work. Just understand those are properties we've seen, alternate interior angles. All right, from that, if we use 31 degrees, there's that. I've got opposite, I've got hypotenuse, and that's what I'm looking for. If I use 59, I've got adjacent, I've got hypotenuse. They'll both work. Okay? Now, since we've got the 31, that's what we use. So I've got sine of 31 equals opposite, which is 1300, over x. Now, in the last section, we saw how to solve this. We cross multiply. That gives you x times the sine of 31 equals 1300. Then you divide by the sine of 31. So x equals, and from there you can put that right in your calculator. So we'll go 1300 divided by the sine of 31. That gives you 2,524.1 feet, and there you go. So Superman is 2,524.1 feet away from those people, and there's your solution. All right. Hopefully that makes some sense. Angle of elevation, angle of depression. I can't stress enough how careful you need to be. It's just a couple of those things that can be very tricky if you're not careful, but shouldn't be too bad otherwise. All right, if you need my help, contact me on the computer. Good luck on your assignment, and I will see you soon.